Hi, just a quick second channel video, which is a follow-up to my main channel one on the ANENG Socket Tester teardown. And here's the PCB in it with this chippity doodah here, this chip on board. It's a bare die under there. And how I found out that this thing was actually an SD7500 multimeter chipset. And when I first tore it down, I thought, even before I tore it down, I thought, oh, it's just using, a little micro in there or something, a little mixed signal micro to do the measurement. No, it's actually a dedicated multimeter chipset, which with hindsight makes absolute sense. But at the time, I was in, it's just a micro, right? I didn't think about multimeter chipset. So how did we work out that this is an SD7500 here? Well, let's go through a bit of the process, because I spent a little bit of time, didn't spend hours, but I spent maybe 30 minutes dicking around trying to find the chip. But it actually, in the end, it was found by a viewer, somebody on Twitter. So I'll show you that in a minute. Thank you very much, because I actually came up empty-handed on this. But let's just go through the process. Now, of course, what we're looking at here is we know it's a 44-pin chip, right? So the chip isn't actually connected to these pads, but there's some other pads inside, which then there's a bare die in there. It's probably only, that big. It's probably only tiny, right? And then they'll have little bond wires going out. They use a little bonding machine, and you might think that's expensive, but you can, any decent assembly house can, actually do that for you. They can do bare dies, and any semiconductor company will sell you a bare die. And it can actually be cost, you might save a few cents or whatever. And on a product like this, really low cost product, you are saving, saving a few cents matters when you're making, 100,000 of these things, or whatever, however many they make. Probably not that much, but anyway. So we know that almost certainly the bare die in there is going to be, or they might have a smaller footprint in there, for example, that was compatible with a smaller footprint version of the chip, perhaps. But I believe, because it's being gunked like this, it's going to be a bare die. And these bond them over, so it should be the same pin out. Okay, so this is obviously, here's the silkscreen marker up here. So this is obviously pin 1. Okay, so we know it's a 44-pin chip. Okay, but of course microcontrollers and other sorts of things, they often come in various packages, like the same type will come in different packages with different pin configurations and stuff like that. So that confuses things as well. But what do we know? Okay, we've got these test pads here. Okay, so we've got VPP here, okay, and that's the one I pointed out in the video, but we've also got 4 test pads over here. So we know that VPP is on pin 1, okay, because we can physically see it going into that cap there. So this is pin 1. It always goes around anti-clockwise like that. So we know that's pin 1, and it's a 44-pin chip. And then it's got some other programming pins here, which is 44, 42, 40, 39, etc., stuff like that. Okay, and I thought, before I actually reverse engineered the schematic for this, I thought pin 12 down here was actually ground. I thought that was actually ground, but it's not. It turns out that's the COM that's the COM terminal here of the multimeter chipset, which is not ground over here. But anyway, getting ahead of myself. Now, what else have we got? We've got, right, and that's pretty much the only information we can glean. And at the time, I didn't know that I think pin 2 is ground and pin 3 is VDD. No, I think pin 3 is VDD and pin 2 is ground there. But I didn't know that at the time because I hadn't reverse engineered this, and you probably don't have to though. So anyway, let's go. Right, so we're searching for VPP pin 1. So the first thing I thought was, okay, it could be like a PIC micro. I know some of the older school PIC micros have VPP on on pin 1. That's just from rusty old Dave memory here, and I believe that's the actual case, right? So I'd go over to Microchip over here, right, and then I'd search for, use the parametric search tool. Okay, I won't go in. I've done videos on how to do parametric searches and stuff like that, so I won't go through all the details. I want this video to be not 1 hour long, but I searched for what is it, 44 pin packages. Are they here somewhere? I did search for package type. Anyway, I'm sure I did. Maximum speed, hang on. Is there, no, there's not a bar that goes across there. Why is there no bar at the bottom? Oh yeah, there it is. Okay, right. So yeah, anyway, I searched for like 44 pin packages, and these are the ones that came up. So, you know, I went and had a look at a couple of data sheets like this, and pin 1 VPP wasn't a thing, right? And then I had a look at some Atmel variants. Pick own Atmel AVR now. So I thought, oh, you know, maybe it's an AVR or something like that. And I didn't get lucky on pin 1 VPP. So, you know, I kept going. Then I thought, okay, this is a real low cost product. So like it costs like 10, 15 bucks or something, right? It's really low cost product, and it's probably going to use one of these Asian source micros, right? So it's not going to use one of the biggies, like your Microchips or your Atmels or your STs or something like that. It's more likely to use maybe some obscure 8051 variant, you know, some, right? So I thought, oh, maybe it's like a Hicon or something. So I went into Hicon, and once again, I had a look at, you know, just some random Hicon chips here, and I downloaded I got some data sheets for those, and none of them matched up, okay? So at this point, like, you can go into DigiKey. Oh, no, sorry, all my links are wrong. So anyway, so then I thought, like, you could go parametric searching in DigiKey or Mouser, for example, and then like, okay, DigiKey, I know how to spell, right? DigiKey, come on, right? And then you can go Microcontroller, and then you can do, if you don't know brands, this is a good way to do it, right? You can go into microcontrollers here. Okay, and come on, you can do it. Interweb is slow today, okay? And it gives you all the manufacturers down here, okay? These are all like your Western ones, so you won't get any of your Asian source ones. But if you don't, you know, if you're trying to figure out what this chip is, okay, then you can actually narrow this down. And then, of course, you can go over to here, package type, right? And you can go over here, you can sort by number of pins, so you can go 44, so you would just select all the 44s, right? Is it a TQFP? Is it a QFP? T, instead of in front of the TQFP stands for thin. So it's a thin quad flat pack, for example. But anyway, right, exposed pads, they might even have like bare dies, right? So you'd select all the 44 pin micros there, right? There's 5,000, there's almost 5,200 of these suckers, right? So you can apply that, and then you can go, okay, these are all, you know, it's not going to be AMD, right? And like analog devices, it's not going to be any of that. But, you know, here's some like Western manufacturers. It's not going to be a Xilig, you know, NXP, probably not, all right? Motorola, probably not. For like one of these Asian products, more likely one of these Asian sourced parts, right? So you're not really going to find anything on DigiKey or Mouser apart from giving you some, you know, some supplier names and stuff like that. And you might, you know, convenient links to data sheets, for example, so you can go open them real easy and check them out. But unfortunately, there's no way to sort of like search for like pin 1 VPP here, unfortunately, right? So anyway, another way, so if you think, oh, maybe it's an Asian sourced micro, you go to someone like LCSC, which is the Asian equivalent of DigiKey and Mouser and Element 14 and your catalog suppliers, basically. And once again, like, you can search for packages down here. Can you search for pin count? Sorry, I can't remember. I did this quite a few days ago. I'm just shooting this video now. And yeah. Here we go. Come on, you can do it. Package, no. Program size, no. No. Can't search for package. That's annoying. Maybe you can search for GPIO. You know, you can narrow it down using the GPIO, for example, which should be like 2 less. Usually on, you know, a good micro, 2 or 4 pins less than what you need. So you might go, say, 38, 40 IOs or something like that. Anyway, I don't think they a package. No, okay. So silly me. right? LQFP, but once again, they don't sort it by pin number, they sort it by type. So if you want TQFP, it's not as convenient as the DigiKey one that we actually did before, right? So TQFN and, you know, so you'd have to go through and select quite a few of them, but you can go in there and you can apply, and then they've got different sizes as well. That 7x7 is 7mm by 7mm package. So I haven't measured like the size of this thing, but you wouldn't, right? You wouldn't bother going to that sort of detail. But anyway, you can go in there and analog devices, Maxim, let's go back out there for the 7x7, right? And then we get, hang on, no, oh, bugger. No, how do I unapply? Anyway, here's all the manufacturers, right? So here's all a ton of different ones that you wouldn't get from there. But anyway, as it so happens, cut a long story short, right, I used some LCSCs and I was looking at various chips. So I was looking at this one here, whatever this one is, right? It's a slow for loading. So I was just looking at various Asian ones, right? Seeing if I could get lucky and stuff like that. And no, I couldn't. And really the only information we had is VPP on pin 1. But there is more information here, which I totally missed. See if you can see it, right? There's more information here. I'll tell you about that in a minute. But I did totally miss it. So, oh, where's my mouse pointer gone? It's gone. Turn it off, then on again. Okay, I got a fresh battery and we're back, okay? So yeah, I was looking through, you know, various micros, right? I couldn't really find anything. And then I decided, come on, it's 2024. Let's use ChatGPT, shall we? So I actually used ChatGPT 4, okay, and I went find a microcontroller in a 44-pin package that has pin 1 as VPP. I had no idea if this would work, right? But it actually, it gave me a few hints, right? And it goes, you can consider microcontrollers from the PIC18, Q24, and PIC18, Q71 families by Microchip. These processors and they are available in 44-pin packages and include a pin designated as mclear/VPP, right? So it actually knows. This is really interesting stuff, right? The pin serves multiple functions, programming, voltage, blah, 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 right? But it didn't necessarily tie pin 1 on there, right? So, you know, but I hadn't considered those PICs before. I'd looked at a few PICs based on the parametric search, and those ones didn't actually turn up, right? And so I said to it again, VPP on pin 18 on these chips, because I actually went in and checked. My grammar's poor there, on pin 18, is on pin 18 on these chips. I need VPP to be on pin 1. Try again, please, AI. And sure enough, it goes, finding a microcontroller with VPP on pin 1 in a 44-pin package is quite specific. But it knows. This is really quite amazing, right? And based on the information available, there are certain PIC microcontrollers where the mclear VPP pin 1 is typically pin 1. So it's focusing on PICs again. It hasn't sort of re-evaluated its search, I don't think. But sure enough, for instance, modern PIC microcontrollers, which is used for programming, is often assigned to pin 1. This is a common configuration for PICs as indicated in this, and then it gives you, right? And then it gives you this reference here. And this is where it was scraping its, you know, it trained its data on understanding, right, in-circuit programming. So VPP, yeah, is, and that's where it's gotten it. VPP is the programming, PICs either programming mode when 13 volts are placed, usually pin 1 on modern PICs, right? So that's where it was getting that information from. Isn't that interesting? Unfortunately, it didn't help, even though I gave one example of a 16F877. However, it's important to note that particular model is a 40-pin microcontroller, not 44. Is important to check its data sheet, and I went in and checked the data sheet, and I've used that PIC before, and it's not. The 18, 7, no, pin 1 is not VPP there, okay? So, yeah, but still, you know, it did an okay job, at least leading me in the right, and, you know, at least keeping me on track and giving me some things to look in. It would be, anyway, it says it would be best to consult the data sheets. Yeah. Well, that's what I was trying to do. I was hoping that it could bypass it. Anyway, so what is, right. Bloody ads. So what is the trick? Well, in the end, I sort of like gave up at this point. And so I put it on Twitter. Can anyone find this? And remember, have you seen, do you notice any more information there than what we had, than what I was giving you VPP on pin 1? It's obvious, but I totally missed it. I totally missed it. So I put it on X here / Twitter, and I asked if anyone knows, and then people threw a few things at me. But the winner chicken dinner was Bar Steward at InfoSec Exchange, and he said it's an SDIC SD7500 on pin 1, looks to be a multimeter system on chip, which is right up your street, and bang on. So thank you very much. That's how I actually found, thanks to Bar Steward here. And then he goes, how he found it was the second link on Google for the search terms QFP44, VPP, and P54 with file type PDF. And I totally missed it. I like, why P54? And then after I typed that, it dawned on me what it actually was is P54 up here. My mind sort of just went, that's a component designator for the capacitor or the resistor above it. And like maybe like I was viewing it at lower res and it looked like an R54 instead of a P54, maybe. And my mind just totally skipped that as a P54 next to that pad. So yeah, I totally missed it. So we actually have two pieces of information there. As it turns out, the ground down here on pin, what I thought was pin 12, that's a complete furphy. So, you know, if you started searching for that, you would come a gutser. But I was searching, the only information I had was VPP on pin 1, and it's a 44-pin chip, and it's some sort of microcontroller, which a multimeter chipset is a microcontroller, but it just contains all the analog multiplexers and the dual slope ADC and everything else required for multimeter functionality, of course. But that's some extra information. So I actually tried that exact, he said it was the second search term he got. So I tried QFP44, or you could do TQFP. I haven't actually tried that. And he said it was the second search term, but that's not. It gives you an ELAN, Electronics Corp 1. I haven't even looked at that, but it's not there. So that 7500 is not there. So let's try that again with TQFP. So I'm not sure, TQFP 44, yeah. So I'm not sure how he found it. No, that doesn't give anything at all. So I got no idea how that popped up on Google for him. If you've got any idea how it worked, let us know. Try it, see if it pops up for you, but I don't get it. Anyway, it said, you know, like you can put like plus in front, and you can put plus in front like that if you want to, you know, it has to specifically like have that string plus that string in there. And no, so what's this EM 8-bit microcontroller, ELAN Corporation? Let's go down. VPP, boom. Yeah, give us the pin number 15. Nah. See, it's not, sorry, 44, pin number 14. Nah. So that's Kamagutsa. So I'm not sure how he found it. I'm not sure why it showed up in his Google search and it does not show up on mine. But anyway, he found it. Winner, chicken dinner. So yeah, specifically put in that information P54. But it looks like, yeah, he used the right mentality. Searching like this is the right mentality, using the information. If I knew I had that P54, if I had noticed that in the image, I certainly would have started searching for that, and I would have started doing strings like this, VPP, P54, or stuff like that, right? But yeah, anyway, it did show up. Doesn't show up for me. Don't know why. But then, like, you could leave off the file type, and you don't want to specifically search for that. It's still not there. Still not there. Still pulling up PDF data sheets, but nah, it just ain't there. Right? But anyway, somehow he got lucky, and that's how I found it. So thank you very much, Bar Steward. on Twitter for finding that. Otherwise, it wouldn't have been nearly as interesting a video, because I was, after spending like 30 minutes dicking around trying to find things, I went, it's not worth the extra effort kind of thing. I sort of gave up, put it on Twitter, hoping for some Hail Mary, and he's the only one who came up with it. So there you go. But this video is about the techniques you use, right? So you can use your industry knowledge to guess on some manufacturers. Maybe you know this company that manufactures this has used this particular microcontroller before, and usually a lot of companies like to stick to the one type of microcontroller. So if they've got one particular type in another product, you might go, I'll search that first. But I knew that PICs had VPP on pin 1, and there are some older DIP PIC parts which have VPP on pin 1, I believe. So yeah, that was the first place. Then I went into a catalog supplier like DigiKey, for example, and DigiKey. We had the search here. Anyway, you saw the parametric search before, and that can give you other manufacturer names. And then if you want some Asian names, you go to an Asian-sourced catalog supplier like LCSC. They're really quite good, even though the packages here are a bit trickier to actually select 44. You'd have to go through and select all the different variants of 44. So you'd have to go 44, WQFN, then you'd have to go, go up, just keep going to find all the 44s, and then you do Control-Shift, and you include those, right? One's coming up. Sure, no, 45. Oh, no. And come on, you can do it. All right, anyway, you'll eventually hit upon other 44s, 40, 48, and you'll eventually hit upon them, and you can see it's a very long list, right? And then you could just do Control-Shift, and then you select multiple ones like that, and then you apply, and then it narrows it down right to 117 parts down here, I believe. There you go. And it can give you, all right, once again, we're back at PIC again, sort of focusing on that. But it can give you a list of manufacturers, especially Asian manufacturers that you wouldn't have thought of. Like, not many people have heard of Hikon Tech, for example. And ultimately, the 7500, D7500, and PDF is from SD Micro, and it's a multimeter chipset. Boom, and there it is, right? And we had VPP, there it is, VPP on pin 1. Turns out pin 2 is VDD, pin 3 is VSS, pin 12 is the COM terminal, which hooks up to the common of your multimeter, and it's the absolute perfect chip for this sort of application, which is that little socket tester with an LCD that just measures mains voltages and whatnot. So yeah, absolutely perfect thing to have, and it's even got the non-contact voltage circuit in it. Anyway, did that as part of my video, so there you go. That's how I found it. In the end, I didn't find it. It was found by Bar Steward, so thank you very much on the Twitters. There you go. Hope you found that interesting. If you did, please give it a big thumbs up. As always, discuss down below. Catch you next time.